Hello guys and welcome to this special session which entails endogenous switching regression with Movestay package in Stata. And we have looked at some of the key terms: endogenous switching regression or ESR, which refers to a method for analyzing outcomes when people self-select into different groups. For example, each workers are choosing different jobs and we need to understand what's endogenous. Simply means comes from within, and the choice is influenced by hidden factors also affecting the outcome. Switching simply means that the outcome equation changes depending on the group that is selected. And the regression, which is commonly used in statistics, is simply a statistical model which is used to predict one variable based on others. Why ESR, endogenous switching regression? Why do we need it? Maybe for example, we have two job types, take and non-take job, and people might choose their job type based on factors such as education, age, experience, among other factors. And the same factors that influence job choice may also influence salary, and this in turn will create a selection bias. And selection bias means that when you use a regular regression would give us biased result. This is the general Stata syntax. We have to issue movie stay command and then selection equation, the outcome equation for group 1 and outcome equation for group 2. And this is what it does. This equation, first it estimates the probability of being in each group. Remember, group can be non-technical or technical, and it corrects for selection bias when maybe someone is biased to belong in non-technical when they must be or they should be in technical. And now lastly, it gives separate outcome model for each group. And we'll have our sample data that will use it in Stata when we transition to practical part. But let us first of all try to go through what this data will entail. We have some columns like private, and in this column we will have something like 1, and 1 will imply that if this worker is in private sector, and 0 will imply that the worker is in public sector. We have predictors or independent variables such as m_s1, which simply stands for marital status. We have job hold, or simply job tenure or holding. And we also have wage equations or regime specific outcomes, where one equation will be estimated for private workers, another for public workers, and more. We'll have to set up our Stata environment by importing the Excel file, and this is the syntax. The dataset will be called a Movestay sample data2.xlsx, and summarizing. So browsing is like viewing your data like a spreadsheet, describing like viewing your columns, like summarizing, giving your summary statistics. So we are going to do this in our practical part. And now this is the general syntax that we are going to run in Stata. We have Movestay, and then we have this command lmo wage, and any other variables are just similar, so don't worry about this. We are going to learn this when we transition to practical part. And just remember that this one is the wage for public employee, and this is wage for private employee. And we want to issue the select command. We say that private is equal to ms1 job hold, and we run or we execute our command. First of all, I have some explanation before doing the real practical part. So part 1 of this equation will entail selection equation, and which is simply stands for factors that decide the job type, such as education, experience, age, and similar. The second part, the outcome equation for public and the outcome equation for private. So this is the outcome equation for public, and the outcome equation for private employee. And the third part is the last part is the select, which is Stata to use a selection model. And this is the part we're using select, and we're going to understand this even better. And how to interpret this result, we need to focus on three parts. Selection equation. So, for example, which factors push someone into public versus private sector? And B will be like outcome equation. So, how education, age, region, among other variables affect wage in each group. And draw, which simply is equivalent to correlation between the selection and the outcome errors. And in case the row is not equal to 0 or is non-zero, then the selection bias exists. When do we have to use ESR? When we have two or more regimes or groups, when there is self-selection into groups, when we have suspected selection bias, and when there is need to compare effects across groups. Key takeaways before we proceed now to practical part is that ESR helps fix bias when group choice is not random, and Movestay makes it easy in Stata. And we need to always think about selection variables versus the outcome variables cleanly before coming out with our model. See you in the practical part. Thank you. Hello guys, welcome again at this practical part. And so right away, let me just open the practical part or the coding section. So we are going to look at maximum likelihood estimation of endogenous switching regression model with the practical version, because we just looked at the theoretical part. And in this session, we'll be using a Movestay with Stata version of number 15. And I have given us a code to install the latest version of Movestay package, because before you use it, you need to have this package installed. And I'm giving this URL. Don't worry, because I'm going to attach this to this video, and you are going to get it raw plus the dataset. And you need now to import the dataset that you will be using. So let me first of all minimize, and I don't want to install this because it's already loaded. Let me just load our data. Let me expand my screen. I'm loading the data, and you can browse this data to check how it looks like. And this is how this data looks like. We have column called private, we have LMO wage, we have age, we have age 2, which is simply the square root of the age, not square root but the square of age. We have edu 1, 3, edu 4, edu 5, region 2, region 3, region 4, and marital status, as well as job hold. I assume that now we are prior to the variables that we'll be using. We have variables like private, which indicates that whether someone is working in a private entity or a public entity. We have wage, that someone's being paid when in private or in public organization. We have age and square root of age. We have education levels. We have regions, marital status, jobs, and similar. And let us have a look at what we want to look at. We are aware that we want to do Movestay model, and in summary, we want to estimate a switching regression model with endogenous selection, and sometimes it's called Movestay model by Dubin McFadden of 1984. And we have subsections that we will look at. We will start with the first part, which is selection equation, and will entail two parameters. We have private and predictor. So private will be our dependent variable, and 1 will indicate if the worker is in private sector, and 0 if the person works in public sector. And the predictors or independent variables will include MS1, which simply stands for marital status, job hold, or simply job tenure or holding, among other variables as we have seen them. And remember, this is simply a probit model, which will explain the probability of choosing private over public employment. And part 2, we will look at wage equations, and this simply is equivalent to regime specific outcomes. How this wage varies when compared to age, level of education, regions where this person comes from, etc. And remember that one wage equation will be estimated for private workers, and we also have another wage equation which uh, would be estimated for public workers. And also coefficients might differ across the two regimes. And if I say regimes, just remember those are the groups. And in this case, we have private and public sector. And part 3, we will also look at correlation for section bias. So, for example, workers select into private or public groups. And Movestay will account for correlation between the selection and the wage equation to avoid biased wage estimates. And the last part I will not cover, it's out of this scope. I've just given you a hint that you will do on your own. So you can do counterfactual to test wages and decomposition. For example, you can estimate what private workers will earn if in public jobs, for example, as well as you can also estimate what public workers will earn if in private jobs. And remember, this will allow the composition of wage gaps into one, a selection effect, which entails the differences due to who selects into each job type. And finally, the treatment effect, which is simply the differences in wage between the sectors. Now, we want to look at the actual model. So, allow me to write the code so we can look at it. So this is the code from Movestay with the element wage, with age squared, education levels, regions, among others. And this is for public, and we have similar for private part. So for private sector, or someone in the private sector will also have the same, because we want just to compare the same terms. And now we have select private based on marital status and job hold. Now guys, this is our final equation that we want to run and now analyze what has just happened. So I will select this, and we can now run the code. It is initializing, taking some time before it loads, and it's over. This is the overall computation of our model from here all the way this part. So we have several parts that we would like to look, but however in this case we might just focus on this. We're also going to focus on this. Wages for someone in public represented by here, and with some factors that affect, or which factors that this wage depends on, like such age, education, regions, among others. And we're checking whether there is statistical significant or not. And the same way to the wage for that person who is working in private sector. And now we have also some part of interesting section, which is entails row. Remember, row not simply stands for the row for someone working in public sector, and row 1 for someone working in a private sector. So to save you the time, I've summarized this into a do file. So let us move do file and check what is there. Hello guys, this is the summary of the result of what we've just seen in Stata. Oh yeah, I have managed to summarize this result and interpretation of the result for guys from private and public. And we're starting with the first one, selection equation, where the private is equal to 1 entail someone who is in the private sector. And we realize that for marital status, we got something like this. Maybe let me revisit here. Marital status. Here, this is where marital status is. We are getting this coefficient. That's what exactly is here. And for married, which simply stands for marital status category, workers are significantly more likely to be in the private sector based on this higher coefficient. And on job hold, or simply job tenure, we have 0.129. Simply means that the longer the tenure increases, the probability of working in private sector. And moving on the wage equation, that is public sector, based on the wage, the public sector wage is called LMO, wage not, or wage 0. And age effect is not statistical significant based on age 1, both age, you can say age and age squared. So here, these are the age I'm talking about, this one. You can see here, these two values are not statistically significant. The first one is here, 0.28228 and 0.260. They are not statistically significant. And for education, we have this kind of result. I hope you will check. And simply these dummies are all of them are negative relative to this omitted category. And checking on regions, you realize that they have significant differences like negative this, positive this, and negative this. You have big regional wage differences. And now looking at the third part, which is wage equation, and basing on now private, we've looked at public sector, which is LMO wage 1. So we realize that these are the this is the result for wage, and realize that we have at least 10% level. So in private sector, wage rise with age, but at a decreasing rate. That's why you have this negative sign, this negative. And education, we also realize that it's not statistically significant. So education is here on wage. This is not statistically significant, as you can see here, from all the way from here to this, not statistically significant. Checking on the p-values, this is the p-value column, not statistically significant. And region as well is not statistically significant. And now we can look at the correlation or rho and sigmas. We have this value of sigma for sigma naught and sigma 1, which simply represents the wage residual variances, and rho Row note is equals to 0.857. This is row note here. This is the row note, and this is row 1. And for row note, it's very strong positive correlation between unobservables and in selection or private choice and public wage outcome. And row 1, which is it's not strong selection bias in private wage equation. And finally, you have other parameters like chi-square, and now final model is statistical significant. Now, since the final model is statistical significant, it means that we'll have to do what? To reject the independent, or simply we reject the null hypothesis, which says that there's no statistical significant difference in what we're trying to test. And finally, we can have the summary of what we've looked at. So in short, workers who self-select into the private sector differ systematically based on marital status and tenure, and wage responds differently to education across public versus private sector. And the public sector shows strong, significant negative coefficient, which is relative to the base group. And on the other hand, private sector also shows weaker education effects. And age matters in private but not in public. In regression, disparities is large in both sectors. That is in 3 regions, which is premium. Now guys, this is the end. Hello guys, this is the end, and I'm going to post everything here in this video with all the notes and the data, so you can get and practice. And thank you for supporting my work. Thank you for everything.